Swayam Prabha. Digital India. Educated India.
Welcome to the next big idea. An incredible journey of innovation, passion, and game-changing ideas. Let's see what this team brings to the table.
Good evening, members of the jury. We are Team Aquasol and we are here to solve India's biggest water crisis, which is our soapy grey water filtration system. I'm very sure you might be using dishwashers and washing machine at your home. One day I was seeing my mom using it, and I was shocked to see where's the water, approximately 150 liters of water being wasted on. And there was literally no solution in India or where in the world, a cost-effective solution to cure this. And so we are here to solve this issue. So what are the ideas? Basically, we have used a set of filters, and we have made 3 MVPs to be sure. First is we have developed our own filters, own indigenous filters, which is not dependent on the stereotypic filtration process, but it is based on absorption process. That filtration name is AquaClean, where the AquaClean is based on zeolites and other ion exchange reagents, which is the main component of removing the soapy particles from the outlet water. Next is the RO system. You have seen a conventional RO system where there is 75% wastage of water, and that's literally too much. Wherein we bring our own designs, our own new patent, filed patent model, wherein there's absolutely no wastage of water and there's 100% outlet of pure fresh water, and the wastewater re-incurs and has space to pass. And next, to incur difference, to have an interface between the hardware and the hardware and the customer, we include our own IoT model, wherein the AquaCheck system checks for 4 basic sensors, which is of TDS, pH value, dissolved oxygen, and turbidity sensors, and shows on the interface, live interface app, whether the water is safe to drink, what's the condition of the water and all, and whether the filter needs to be changed or replaced or not. Come to the cost of the model. Well, when I say effective and cost efficient, it has to be. The prototype which you developed and which we are using under the testing phase costs somewhere around 50,000 rupees, and these are the whole breakdown estimation of what the whole particle includes. Come to the maintenance. The maintenance costs 6,100 rupees, where the filter gets changed in every 6 months, and this is the whole monthly yearly cost for the product maintenance. So the main thing we require for the product is electricity and water, and that's what we are solving here. The water bills which needs to be paid by the industries and large MNCs like laundry industry and all, and it's a hefty amount which will be showing where the amount costs to. So, but what is the amount we are saving to, and what is the cost of electricity and those non-renewable sources which we are using? So we have calculated the whole estimation, like where the electricity cost comes per day of 2.5 rupees, wherein the water cost, which is commercial use, we have taken at 31.2 liters of commercial water per 1,000 liters, which is given by the Hindu as per the Maharashtra state. So when we calculate the cost of one washing machine, which runs for 40 cycles per day for 15 minutes as a running time, the water cost per month given by the industry is 5,616 rupees. Along with the electricity bill comes somewhere to the whole estimation, and we are saving a net worth of 46,000 rupees 914 per washing machine of the industry. This is the whole model we are based on. In short, as 31.2 rupees was the cost of per 1,000 liter, our product gives a cost of 10 rupees per 1,000 liters. Coming to the business model of what Aquasol is based on. Well, we are working on the B2B business to business model, wherein we have 3 types we are focusing on, which is manufacturing. Well, we are having our own manufacturing plants. We're having own service-based ecosystem, and we're doing everything on our own. Second is the partnership, where we'll be tying up with services like AWS and all for providing us with IoT services. And third is the IP rights, whereon right as a like initial phase, we are focused on the IP rights segment, wherein we'll be giving our patent rights to the already pre-manufactured companies. For naming a few, like Bosch and LG, which is both in the washing machine segment and the filtration segment, they have their own whole ecosystem of filtration, whole ecosystem manufacturing. They will manufacturing us, and we'll be getting loyalty from their for the product. What is the social enterprise of the model? Well, the social enterprises, it is based on the 6th UN Sustainable Development Goals, which is water cleanliness and sanitization. We also had a few talks with the companies like startup companies for the CSR funds, and which like a big MNCs, which will be funding us because we come under sustainability model. And next is the presentation support, like AWS and IoT. These support Microsoft startups. As we are a member of Microsoft's community from a college, we are getting the support of free IoT services and web services from AWS and even Microsoft. So in that way, we incur the company cost to a very less amount. Next is what is a growth and marketing strategy? Well, the government partnerships. Well, so far we are present somewhere, and we also have backed an offer by IIT Madras Incubation Center, TBI, under the scheme of Startup India Innovation. We can get grants from these companies and all. Next is the ergonomicity, wherein we integrate with the existing systems. So our basic aim right now is to, like washing machine, dishwasher, which are already available, we want to make the product so compact that these can fit into the outlet of these system, and it whole becomes as a single unit rather than an extensional unit. Next is the communities and environmental officers. Well, if you go to big chains and industrial hotels like ITCs, Taj and all, everyone is acquiring environmental officers for their ecosystem, where we connect with them, and they are the point of contact for us and for the big hotel MNCs and the laundry sectors. Coming to the target size. Well, we are targeting a very niche market, and it's a very untouched market right now, because there is no proper solution for this thing, and no one has ever thought, because it simply gets wasted. But caring for the nature, we have thought the laundry sector in India is of 20,000 crores for financial 2023, which is based on the Economic Times data. And coming to the landromats, we don't have any data for India, but in the US, it states to 300,000 US dollars. Basically, when the landromats have an annual average turnover of this much, their utility cost, which consists of water and the electricity cost, comes to 70,000, which is like approximately 25%. So our, you might be confused where our target segment is. We are not targeting the big, industrial areas and like residential areas and all, because it's too hectic to manage and all. We are targeting luxury hotels, restaurants, landromats, and laundry industries, wherein the market is really big. Why us? Why Aquasol? Basically, Aquasol, when I show the product demonstration, you'll be surprised to know how this thing is working, and we want to really keep it a bit of secret because.
So, can you tell me in a short course, so what is your product?
So basically, our product is a hardware product.
Okay.
It is a software. It has a set of filters which filter the soapy grey water.
So it filters the
Soapy grey water.
soapy grey water.
Of washing machine and dishwashers.
Okay.
Just 30 seconds video, which like we cannot bring the hardware over here for demonstration purpose. So that was a bucket which had a 30% concentrated detergent dissolved in the water. First, it goes to sediment filter, which is completely designed by own, which we have made changes, and all our. This is. Then comes the silver carbon filter, which we have again. This is the RO, wherein there's no wastage of water, and the water from the RO, reverse RO, goes back to the inlet because of the pressure difference which we have created, and the whole system which we have developed on our own. This is IoT system for multi-system, and that is the UV lamp. This is the backend of the app this is the backend of the app which shows the each and every like whole customizer. You can customize it to which at what rate you want to show the ratings, like the readings of the water system.
What is your uniqueness of your product?
So uniqueness, you might have seen RO. So there's 75% wastage of water. In our RO, there's no wastage of water. First, there's no water outlet itself.
What are you going to target on an audience? So for example, you told you do some patented technologies with RO, patented technologies with sedimentation, and that's a different area of expertise that you needed, okay? And then you say some kind of IoT devices that are being attached towards that. Correct, and sir. That is a separate expertise that is involving, okay? Correct, and then you also talking about involving this with existing solutions like washing machines and compacting your product into a single unit and all those things. Correct, again, that is a separate set of expertise, okay? Correct, so you are talking about multiple areas where that need to be concentrated and then should be channelized and then it should be converted as a product, where even today if you take aqua filters or if you take an RO filter manufacturing company will be a separate company, whereas the IoT devices producing company will be a separate company. All those things will be like a plug and play actions currently. Yes, sir. But you're telling me that all these things are done into a single package that you're already telling like a correct, patented work. So I just want to know what is the innovation that you claim, okay, is what you tell it as a patented product. Correct, first thing. Okay. Second question I just want to know is why I need so much of intervention of IoT, which I need to know only the quality of the water, where you show me some boats and pump and all those things happening. No? So why I need a IoT device? Eventually, if the work process is seamless, and if you are involving what kind of sensors you are involving to ensure that the water quality is being done. And the third thing is what is the test that you have done that you're claiming is
Yes,
is so perfect. Like you just
Yes, sir.
prove me with some test materials that you have done.
So coming to the first question, so basically this product will be attached at the outlet. Like in hotel chains, there's a lot of washing machines and they have a common inlet pipe, outlet pipe. It will be attached over there, and that is that is a future goal to compact it within the washing machine itself.
You tell me that there's no waste of water. I'm not believing you. Tell me what you have done.
So we
I'm not
had a
going to
re-
steal your idea, but just give me a glimpse that I can't understand how you're going to do with that.
So we went to a couple of research papers and all. So we saw that why is the water being wasted? The answer is it is not a waste water. It is we are not giving time or basically creating a pressure difference to further letting the water to pass through the filters. So we reverse engineered in a way where the water is again back pushed into the inlet of the RO, and water is allowed to, like we are living the waters from dinosaur age. It is reverse engineering, which no one has thought. That's why I never, say this thing, because right now this idea is being used by Kent. I went to India's Future Tycoon, and they have taken me the rights. They asked me to get it patent right now, which we are working on, and I'm selling to Kent right now. Kent has taken over this to be open, very open right now. So next thing is, filters, they are based on separation method. So say you pass the water, the sediments are left, but the AquaClean filter is not a sediment filter. It is an absorption filter. There's no absorption filter based as such in India. I would say it's based in US, but that is not for soapy water. So we use ion exchange resins. As the soaps are basic in nature, we are using a acid ion exchange resin to eliminate the soapy nature of the water. Second, we have zeolites. So again, it is a reverse engineered.
I just got your idea.
Yes.
He gave me a good explanation. Okay. So my question is, when you go for a claim like this,
Correct, sir.
don't say it is 100%. Okay. So 100% means zero waste.
Correct, sir.
If you put 40% water also, again you do the reverse RO filtration, again it will produce some waste.
So I have a reason for 100% claim, not 100%, say 95% claim.
But be careful with the stats,
sir.
because it is easily can manipulate me. See, if you
Correct, sir.
tell me 95% of waste declaration, then okay, I can believe on you.
Yes, sir.
If you say 100% means there is a breakage of thing, like you're telling me, like
we say like 100% outlet with 95% purity. To be very
that
precise.
doesn't sounds well.
No,
Like
so
that doesn't
so like,
sound it to me the right way.
95% clarity, because 5% would be remaining in the filter itself, which is being sedimented.
Why is this so much of IoT I need? Like, what is the purpose of all those things?
So basically, it is a very simple IoT, I would say. So the purpose is just to know, like what happens, there are a lot of water qualities when you use dyes. So we are giving it a very larger aspect. When you use dyes in water, every dye, like cheaper dyes, they have a different reaction in water. So just to know what is the turbidity of water, like a lot of dyes leave color. So as the ecology which are developed is from the outlet water, it goes to the, we push the water, clean water to the underground water, so that it comes again as a fresh water, you recycle it at your home and use it for drinking purpose.
What thing you're doing? Like, you use sensors, or you
Yes, sir,
use
you're using sensors, basically 4 sensors. One is pH sensor. So
Okay.
because the water is basic in nature, so you need to know it's whether in a neutralized state or not. Second, stability sensor, whether to see whether the water is still clear, it's like still
all
the
these sensors are kept in which locate of water? Like
So at the end of the filtration process,
outlet.
Yes, sir. So when you see, okay, so to be very clear, when this is the UV lamp, the pipe of the UV lamp, UV is outside the water pipe. There itself, we have made holes, and we are this is the TDS sensor, which you have basically incorporated in the pipe itself. So as the water flows, the sensor keeps reading the data, and it projects on the IoT or on the screen, which is even there on the product itself.
Why are you making it so complex by using IoT? Just make me clarify.
The customer should know, because they won't believe me, right? When I say the water is clear, let it go. You need to see some proof. So this is one of the industrial proof, I would say, using IoT to say whether the water is clear or not.
Basically using different sensors and such. It's just for means monitoring the stuff, so that the water that you are getting is actually pure. Because we are also saying that after 6 months we'll be actually changing the filters and all of that, so that you can monitor it.
Yeah, so you were saying that you're going to focus on luxury hotels, restaurant, laundromats, laundry industry, right? But this product that you're talking about focuses on washing machines, and your economic city talks about talking to Bosch and, incorporating your product to other MNC companies, washing machines, and so on and so forth.
So we tried all our hands on all the things to know what the market wants. We got to know water companies want the RO system. Incubators like IIT Madras and these chemical industries want the AquaClean system, which is the absorption filter. So we got to know the two main things which our product has. Now we are planning to go to patent these two right now and sell on these two things rather than making the whole product. This is what we have thought as of now.
And right now, that's one of the main reasons that we are to approach the LG and Bosch, because they are in both of the industries. So they will be much more interested in the whole product than individually splitting it.
Yeah, that's a good approach. Go ahead. All the best.
Thank you so much, sir.
And now it's time for judges' opinion about the pitch. So, it was a good one.